Number 4, we want to test mean of the null. Mean is equal to 20 versus alternative null is less than 20. Simple random sample size 16. Obtained from a population that is known to be normally distributed. Part A, we want to find the test statistic. We're going to go to StatCrunch. This is looking different. There we go. T, one sample with summary. The sample mean is 18.4. Sample standard deviation is 4.3. Sample size was 16. The mean is 20. We are testing less than, and we're going to compute to get our test statistic. 2 decimal places, negative 1.49 when rounded, negative 1.49. This is a left tail test because of less than, so B is giving us the left tail test. And then approximate the p-value. So the p-value is given to be 0.078, so 7, almost 8%. So 7, 8 fall between 5 and 10. And then will the researcher test at alpha equals 5%? So the p-value is greater than alpha, so we will not reject. If the p-value is less than alpha, we reject the null. So since p-value is 7 and the null is 5, this is greater, so we will not reject. Researcher will not reject the null since p is not less than alpha, so A matches what our conclusion should be. All right, number 5, we got 7 parts. We're going to test null, mean is 49 versus alternative mean is not equal to, so 2-tailed. Sample size is 35. We're not told normally distributed, but we can assume because greater than 30. So does this have to be normally distributed? No, since the size is at least 30. Underlying population does not need to be normally distributed. So A. We're going to find the test statistic. So I'm going to go back to stat. T, one sample summary. Sample mean 52.4. Standard deviation 7.6. Sample size was 35. This mean is 49. And we're testing not equal, and we don't have a level of confidence yet. Test statistic is 2.64 or 2.65 when rounded. 2.65. This is a 2-tail, so A shows the 2 tails. We're going to approximate the p-value. So the p-value here is giving us 0.01, so a little bit more than 1%. So observing a sample statistic as extreme or more extreme, this is just from the definition of p-value. The one observed, then the one observed, assuming that the null is true, is in the range. So the p-value is between 0, 1, and 2. Because the p-value, if we research or we test this at alpha equals 0.01, p-value is greater than alpha, we will not reject. The p-value is greater than alpha. The researcher will fail to reject, will not reject the null. If we do a 99% confidence interval, so we're going to do options, edit. We're going to come down here and say confidence interval for mean, change this to 99%. Compute, and it gives us lower and upper limit. So 3 decimal places, 48,895 is the lower bound. and the upper bound 55.904. 55, well, actually 55.905. 55.905. And then if we look at this range, 48 to 55, 49 falls in that range. So it could be equal to. So because the value 49 lies within the confidence interval, we fail to reject the null. We reject it if it falls on the outside.